Hello and welcome to this North Korean video about hacking JWT tokens by forging signatures. What we're going to talk about is how we can gain access to areas of websites that we don't have the right privilege to get to by forging our own token. So let's jump in and have a look at this. We have a website here that uses JWT tokens to be able to confer authorization to this website. I'm going to log in as a demo user that I have created previously and show you that I have a landing page that I can get to, that when I try and go to an admin area, I will get rejected. We get this message requires an elevated role. Now, what this means is that this application understands that there are multiple different roles and that while I may have the user permission, I do not have the admin permission. So let's try and figure out how it knows that, how it's able to understand that information. Because for this site, it's using JWTs. So I can right click and go to inspect. And if I go to the storage area over here, we can see that I have a token for this website. I'm just going to copy that and put that into a notepad document so you can see it a bit bigger. This is what a JWT token looks like. JWT stands for JSON Web Token. And I know that the name token is in it, but I will continue to call it a JWT token. So what these are is they are tokens that are made up of headers, this section here, payloads, this section here, and signatures, this section here. Okay, and this is the structure of a JWT. If you ever see a cookie value or a token that is data dot data dot data, you should be thinking this is potentially a JWT. That is the structure they have to be in. While you may look at this and think, okay, that's great, but I can't understand what this means, it's actually not that difficult to be able to put it in a format that we can understand. This is just base 64 encoded data, apart from the signature. So what I'm going to do is I'm just going to simply copy this, put up a copy of burp, and if I put this into the decoder, and make sure it's decoding as base 64, to put it in text to make it a bit nicer, what we can see is that we have, again, I'm going to copy this and put it in the notepad so it's easier to see. We have our header information. This is a JWT token using the algorithm HS256 to generate a signature. This is the payload data. Key information for us for this application is user. There's our username, role. There's our user permission level. And then we have a signature that is used to validate that none of this data has been manipulated in transit. Now, different applications can have different data in their payload. There is no limit to the amount of data that they can put into a payload, but it is always just base 64 encoded. So what can we do with this? Well, now we can read this and understand that we are sending data to the application and telling it that we're a user. We could try and manipulate this and say, okay, well, what happens if I change this to admin? So I'm going to make a quick copy of this. This is our legitimate token. And okay, I didn't need to take a copy. And what I'm going to do is in burp, I am going to get rid of the head. In fact, I'm just going to copy. Here we go. I'm going to copy the payload into burp. And what I'm going to do is change this to admin, encode it as base 64, and generate a new token. I'm going to use the same header. I'm going to use my new payload. You can see that we've got equals characters that base64 commonly uses for padding. I'm going to ignore those. If ever you're manipulating JWT tokens, you always ignore the padding characters, and I'm going to get my signature. Now this is going to fail. As much as this looks like I've been able to just simply manipulate the user role, this is going to fail. And the reason for that is because our header is telling the application that we're using the HS256 hashing algorithm, and my signature does not match with the data being hashed. So if I paste this in here, my new token, and try and go to admin controls, you can see you are not authorized to view this page. So if we have a quick think about what's going on, we have a header that tells us that it's a JWT token, and it tells us the algorithm that is being used to create the signature. We have a payload that tells the application data that it wants to know, and then we have our signature. If we focus over here, we know the algorithm that is defined in the header. We can change it if we want, but ultimately, for the minute, that is defined in the header. We've got the header information. We've got the payload information. We can do with that what we want. We don't have this secret key. We don't have the ability to use all the information needed to generate a new signature. So when we are changing that role from user to admin, what's happening is that when the signature is being generated, it's not using that admin role, because that's our modification, that's our manipulation. We've changed that. So when we're changing the payload value, the signature is going to be wrong. So what we've got to do is figure out a way to get that signature to be correct. What we've got to do is we've got to figure out a way to get that key. So let's take our legitimate JWT, and what we're going to do is we're going to use John the Ripper to see if we can crack this and turn around and say, let's get the key. To do that, I'm just going to load up my Kali. I'm going to create a file that has my JWT token. So you can see it's just, that's it, the legitimate JWT token that is generated, and we are going to try and crack it. Now we're going to tell John what format it's in. Okay, we know it's a HS256. That's HMAC SHA-256. So we know the format that's being used. John is now going to see if it can get that secret key. And it's been able to crack it. So now we have that key. We've got the ability to forge our own signatures. We had the only piece of information that was unknown to us. Now we know it. So let's go back to our web app. We can't get to the app in control, but now we know how to forge a signature. So what we're going to do is we're going to intercept this invert, and we're going to forge a signature. Okay, so I have the JWT editor extension on here. I recommend, if you're playing around with web apps, to get that. It's incredibly helpful. So we want to be able to forge a signature. We have all the information needed to forge a signature. We can leverage the fact that HS256 is a symmetric algorithm, meaning that now we've got that key, we can sign whatever we want. If we go to our JWT editor, what we can do is we can turn around and say, I'm going to go and create a new key. I've got the details. It was 133777, I believe. Let me just go check. Yep, 133777. And I'm going to hit generate. Okay, so this is the ID. This is the key that I'm going to use. Let me just delete that to get rid of it so we don't confuse anything. This is the key that I have just generated. So when I try and go to the admin portal, I can see in my JSON Web Token that I'm a user. What I want to do is I want to say, actually, I am an administrator, and I am going to sign this with the signing key I have created. And you can see that signature that just changed. So now if I forward this, there we go. I am now in the admin area. Okay, I can now try and click buttons, but because I've done it in Burp, I'm back to using the legitimate token. Okay, so again, if we want to try and show that again, my token that I have in my browser, go back to the decoder. This one that is stored in the browser is showing me as a user. So when I want to go to another admin area, I can change my user role to admin. And to make sure the signature is correct, I have to sign it. So watch this signature area. It will change as I sign it. Okay, and now I can go to these different areas of the application. Okay, thanks so much for watching. That was how we can forge JWT tokens, how we are able to then leverage that to gain access to application areas that we shouldn't be able to get to.